All right, hello everyone. We are back for day 2 of the closing packet. So let me go ahead and share my screen with you. Let's see here. This isn't taking too long to do these problems. Hopefully you're doing okay on them. All right, okay, so here we go. Let's do it. We're going to do pages 4, 5, and 6 today, and we're going to continue with logs for right now. So it says here to use the change of base formula to evaluate each expression. So for this one, if we were going to solve this, we could do this 2 ways actually. The change of base formula says we need to do log of 8 divided by log of 32. And we can get our calculator. Plugging mine in. We can get our calculator and we can punch that in. Now, if you have a newer calculator though, you can go to Alpha Window. I don't know if you can see that, it's backwards. Alpha Window, and you can go to number 5, log base, and that'll give you the log of any base that you want, not just base 10, and it gives you 0.6. So 0.6 is the answer. If you have an older calculator, you'll have to use the change of base formula. Okay, so for these next 3 problems, these ones are tough. Now we're going to be solving some log equations, and it's not always easy. So the first thing we need to do is here, we need to get our logs together into one single log. So we're going to use our log properties, use the properties of logs to solve these equations. So the 2 is going to move up to here. This becomes log of 5 squared, which is 25, plus log x equals 2. Now we're going to combine those 2 logs into one single log. And the way that you do that is, if you remember, if it's plus in between the logs, we combine this as 25 times x equals 2. All right, now when solving these, I always said this was the hardest step for people because they forget what to do. There's a base 10, and we're going to go ahead and rewrite this in its log, or in its exponential form. We're getting rid of the log by doing 10 squared equals 25x. So 10 squared is 100 divided by 25. X equals 4. All right. Let's try number 14 now. Here we go. This one, same thing. We're going to combine this into one single log. So we get log of x times x minus 21 equals 2. There we go. And then we can go ahead and multiply that. So it's log of x squared minus 21x equals 2. Let's get rid of the log by changing it to its exponential form. So 10 squared is 100 equals x squared minus 21x. And then bring the 100 over to the other side because now we have a quadratic to solve. All right, you can use any method you want to here. Of course, my favorite method is to factor if we can. Is this, oh, it is factorable. Nice. So this is what times what's negative 100 adds up to negative 21 would be a positive 25 and a negative 4. All right, so we get 2 answers, but you do need to be careful with logs because sometimes you can get extraneous solutions. So if you go back up to the very original question that was asked, if we were to plug negative 25 into here or there, we're not allowed to take the log of a negative number. So our only answer for this is x equals 4. All right, and then finally number 15, when there's a minus in between logs, we want to go ahead and rewrite that as 4x divided by 5. Okay, so we combined it into one log, and now we want to get rid of the log by writing it in its exponential form. So 10 to the third equals 4x over 5. 10 to the third is 1,000, and then times 5 gives us 5,000. Equals 4x, and then finally divide by 4, x equals 1250. Oh, the year I was born, crazy. All right, here we go, number 18. All right, the population of a bee colony is growing at a rate of 2.3% each year. Ooh, exponential growth. There are currently 3,400 bees. At this rate, how many years will there be 10,200 bees? All right, so we're using the basic formula A equals P1 plus R to the T. So let's see what we have. We have A. That's how many bees are going to be present at the end of this. So 10,200. we also have P because we know how many we started with. We started with 3,400 bees in the colony. And then we also know R. And so this would be 1.023, that's exponential growth. The question mark is T. And so we're gonna need to solve for that. There's a few ways you can do this. You can graph it. You can graph this side y1, that side y2, find the intersect, or we can solve it algebraically. So I'm gonna go ahead and do that. I think solving it graphically is really hard for a lot of people because they have to change their window and it just gets a little tricky. So but unless you're good, I know some of you are really good at the calculator stuff, so you could do it that way. Okay, so I divided that and got exactly 3, and now I have 3 equals 1.023 to the t. And so this is an exponential equation. In order to solve an exponential equation, we're going to take the log of both sides. I'm running out of room here. All right, so I'm gonna go over here. So I have the log of 3 equals, I'm gonna bring the t down, log of 1.023, and then we're going to divide by the log of 1.023 to the other side. 1.023, those reduce, and t gives us, let's see, we're gonna go log 3, close parentheses, and then divide by log 1.023. It's gonna take 48.3 what? Population people each year, so that would be in years, okay? 48.3 years, great. All right, number 19, a certain substance has a half-life. Okay, so we're doing half-life now. And with half-life, we have this equation. Y equals the initial amount, 1/2 to the x over HL, half-life, whatever the half-life is given to us at. So that's our formula. And so a certain substance has a half-life of 14 days. How much will be left after 90 days if your original sample is 75? All right, so we're looking for Y this time. So we have a sample of 75. The decay factor on half-life is always 1/2, half-life, and then X divided by 14. So how much is gonna be worth after 90 days? We're gonna take 90 and plug it into there. So in your calculator, you're gonna go 75 times 0.5 to the 90 divided by 14. And you should get that it's only about 0.877, we'll just go 87 milligrams. There you go. Okay, now for some multiple choice. Which of the following functions represents exponential growth? All right, do you see it? Do you see which one is the growth? I do. This is decay. This one, 3/8 is decay, and 9.98 is decay. This is the only one that's growth. You only want to look at the number in the parentheses because that is your growth or decay factor. Use the change of base formula to rewrite log base 7 of 16 using common logs. All right, so using basic log, it would be log 16 divided by log 7. So there it is. All right, 2 more to go. Here we go. Which of the following is written as a single natural log? Okay, so for this one, we need to get this into one single natural log. So we have 2 natural log of 10 minus natural log of 5. These are 2 properties happening here. The 2 is gonna move up on top. Okay, we're gonna write as one single natural log. So 10 squared is 100. And the minus tells us to divide. So I get the natural log of 20. And so the answer would be D. All right, and then which of the following is the correct expansion? All right, so now we have 1, 2, 3 different things here, and they're all gonna be log base 6. So I have log base 6 of x squared, 2 will move to the front. That's multiplied times y, so we're gonna add log base 6 of y, and the z is on the bottom, so we subtract log base 6 of z and move the 4 to the front. So do any of those look like that? I think it's H. Yes, H looks exactly like it. All right, now this problem has been one of my favorite problems because this is actually something that happened to me. It was crazy, like these numbers and everything. So for the years 2000 to 2005, the median price of a single family home in the United States can be approximated by the exponential function right here. I purchased my first home in 2000. And I purchased it for $220,000, which seems like a steal right now, especially with the housing up so high. But that's what the starting would be for the year 2000 to be just about what I paid for my house, which is kind of funny. All right, so, and this only happened to be for 2000 to 2005, because after that, the market kind of took a crash and housing went back down a little bit. So, okay, so here we go. Letter A, what is the growth rate? Well, the growth rate is right here. The growth rate is not 1.087. That is not the growth rate. The growth rate is to like kind of ignore the 1, because this is 1 plus R. So it's 0.087, and as a percentage, it's 8.7%. That means that people who purchased their home in 2000 were getting 8.7% return on their investments in their home, which is pretty crazy. All right, so what was the median price of a single family home in 2005? So basically, after 5 years, how much is the house worth? And so we don't want to plug in 2005. T is the number of years after 2000. So at 2000, T equals 0. And that's why you get that y-intercept of 227,000. So here we want to plug in T equals 5. So 227, 200, 1.087 to the 5th power. And you go to your calculator, and after buying your home for $227,000 in 5 years, it was then worth $344,791.10. That is a crazy amount that you made equity on your house in only 5 years. All right. Oh, chapter 8. Okay, so now we're moving on to chapter 8. Chapter 8, we started with a worksheet that had to do with inverse and direct variations. And so that's what the start of this chapter is. All right, so write a function that models each variation. When x is 5, y is 15, y varies inversely with x. All right, so set up an equation first. So y varies inversely with x. You have to have a k for constant, and then you have y equals k over x. And so now go ahead and plug in 15 for y, and plug in 5. And so 5 times 15 is what, 75, I think? Yeah. 75, so k equals 75. And then go back to this equation that you have here and put in 75 for k. Because k is not a variable, k is going to be a constant in this problem, and that's what it would be. That would be your answer. All right, so number 2. Z is 6 when x is 4 and y is 3. Z varies directly with y and inversely with x. So there's 2 things happening here. So z equals directly with y, so k times y. Directly means multiplied together, like right there, and then inversely with x. Okay, so let's plug in everything we have. We have z is 6, we have x is 4, we have y is 3. So we'll multiply by 4. 6 times 4 is 24. Divide by 3, k is 8. Go back to this right here, oopsie, and go ahead and plug 8 in for k now. So z equals 8y over x. There it is. All right, excuse me, one more of these. So it says that z varies jointly with x and y. That means they're all joined together. So z equals kxy. Plug the numbers in. Z is 8, x is 2, y is 4. And so k equals 1. So our equation this time would be z equals, and we don't really need to write the 1, z equals xy. All right, now for the next 3, these are the ones that we need to decide whether they are directly proportional to each other. Remember I talked about like being proportionate. As x goes up, y goes up, or if x goes up and y goes down, they're inversely related. So proportions or products, okay. So if a gear with D teeth does P RPMs, how many RPMs does an attached gear with C teeth do? Well, gears are always inversely related. The more teeth, the less RPMs it's going to make. So this one, we want to set up products equal to each other. So D teeth does P RPMs. How many RPMs, I'm going to call that X, do C teeth do? And we're trying to find out how many RPMs. We're trying to solve for X. So X would be D times P divided by C. All right, number 5. Suppose a supply of food will feed 24 students for 5 days. How long will the food last if there are 6 more students that join the team? Okay, so the more students, the less days that the food's going to last. So we need to set up products here. So 24 students times 5 days equals, now 6 more students are coming in. That does not mean 6 times x, it means 30. Because 24 plus 6 is 30 times x. And then we solve. 24 times 5 and then divide by 30. So that would be 4 days the food will last because 6 more kids are coming in. Now, the last one, if I can go 200 miles with 8 gallons of gas, how many gallons of gas do I need to go 350? Well, for this one, we would want to set up a proportion because the more miles that we can go, the more gallons of gas we will need. So 200 miles per 8 gallons of gas equals, I'm going to put 350 on top, x gallons on the bottom. So you set up a proportion and then you solve by cross multiplying. So 200x equals 8 times 350, 2,800, and then divide by 200. So 14. 14 what? 14 gallons. We need 14 gallons of gas to go 350 miles. One more to go. Here we go, last one. All right. Now, these ones are tough. I'm going to tell you on this page, there's a couple of bad problems. Skip number 16. And also we're going to skip number 1 down here. Okay, so a little less than what we need to do. All right, so these are tough. Here we go. So we're going to state any restrictions on the variables and we're going to simplify. For this, there's a few ways to do these problems. I think a lot of you guys chose just to multiply straight across. So 4 times 10 is 40, x, y to the 4th. On the bottom, 5 times 24 is 120, x cubed, y. Okay, and now you need to reduce. So you can use your calculator, go 40 divided by 120, hit math fraction, it gives you 1/3. And then now we have the x's that we need to reduce. So there's 1 up top and there's 3 on the bottom. That's gonna leave us with 2 left on the bottom when we reduce 1 out of there. And then I have 4 y's up top, 1 y on the bottom, so that's gonna give me y cubed. So that's completely simplified. Okay, now for the rest of them to simplify, like this one's a lot different than the first one. This one you need to factor before you simplify. Oh, I didn't give you a multiplication. All right, so this is division, which we're just gonna flip the right one, not the wrong one. We're gonna flip this one and multiply. Okay, so first let's start by, crazy's outside. First, let's start by factoring. So what times what's negative 15 adds up to 2 would be a positive 5 and a negative 3. All right, now I'm going to change this to multiply and I'm going to flip. So I've got a 2 here, and this factors as x plus 2, x minus 2. Now, nothing, oh, just this, that's boring. All right, so that one reduces, and we are left with 2 times x plus 5 over x plus 2, x minus 2. Ugh, that one was dumb. Okay, moving on. Who came up with these problems? All right, number 12. Now for 12 and 14, those two problems, oh, I didn't state the restrictions. Oh. This one over here, x cannot equal 3, negative 2, or positive 2. So anything in the denominator, ever was in the denominator, x cannot, you can't have an x that goes in to make that 0. So those would be it. Okay, so over here, we need a common denominator, and between these two, our common denominator is we need a y minus 1 and a y minus 2. We need them both. Y minus 1 and y minus 2. All right. So if you look at the first fraction right here, it is missing the y minus 2. So we're going to multiply top and bottom by y minus 2. And this one is missing the y minus 1. So we multiply top and bottom and get y minus 1. All right, so now we need to simplify this. We have y squared minus 2y plus y squared minus y. All I did was distribute. And they're all over one common denominator. And then we need to just clean it up. So I have 1y squared, another y squared, gives me 2y squared. And I have minus 3y. And all of this is over, oh no, okay, y minus 1, y minus 2. There we go. Yeah, I'm wondering if my iPad's gonna make it too. All right, so number 14, first factor, and then go ahead and get a common denominator. So what times what's negative 8 adds up to negative 2 would be a negative 4 and a positive 2. And over here, x minus 2, x plus 4, and x minus 4. Okay, a little bit of a lag going on. All right, so now we need to get a common denominator, multiply the whole thing, do all that stuff. I'm trying to think if we can simplify anything here. No, not really. Okay, so here we go. Here's our common denominator. We need an x minus 4, an x plus 2, and an x plus 4. We need that for both of them. And x plus 4, x minus 4, and x plus 2. Okay. So for this one, top and bottom, we can figure out what we're missing, and we're missing the x plus 4. So we need to multiply that by x plus 4 up top, and you would get x squared minus 16 when you FOIL that out. Over here, we are missing the x plus 2. So if we multiply that top and bottom, we would get x squared minus 4. All right, so now let's subtract. Now we're subtracting, so be careful, we have to distribute. So we get x squared minus x squared is gone. Negative 16 minus a negative 4 gives me 12 all over all of this, negative 12. X minus 4, x plus 2, x plus 4. All right, a couple more. Number 15. I should probably plug my iPad in. Hold on real quick. Fast forward the video or something. I paused it. Let me see here. About me, I got this covered. So many things to charge. All right. Okay. Now we're back. Sort of. Living on the edge. All right, so here we go. Number 15. So for these, we need to solve for x. These are a little crazy. This one right here, what I would do is I would just subtract 9 over 28 to the other side. I have 3/4 minus 9 over 28. Oops. 3/4 minus 9 over 28. And that gives me 3/7. So I have 3x plus 2 equals 3/7. And that just makes it a much easier problem to solve now. So what I'm going to do is I'm just going to cross multiply and solve for x. 7 times 3 is 21. 3 times x plus 2 is 3x plus 6. Subtract 6, divide by 3, x equals 5. That was nice, not too hard. All right, over here, this one's a little trickier, number 17. So what we're going to do is we're first going to start by multiplying everything through by the GCF. And in this case, the GCF is x minus 2, x plus 2. Okay, so we're going to go there, there, and there. When we multiply here, we have x minus 4, x minus 2, x plus 2. Okay, you just put these right next to this, and it's all over x minus 2. And this is equal to, you're going to do the same thing here. You have an x minus 2, and then you have times an x minus 2, times an x plus 2, and this is all over x plus 2. And then finally on the last one, you have just a 1 there, so you're just going to write x minus 2, x plus 2, all over x minus 2. Now, that makes it look like we, messed it up even more, but we're going to go ahead and reduce anything that has a match. So we're left with x minus 4 times x plus 2 equals x minus 2 times x minus 2, and then over here plus x plus 2. So we got rid of all of our fractions. Now, we still have a pretty difficult problem to solve. So let's FOIL this out. When you FOIL this out, you get x squared minus 2x minus 8. I went ahead and just did the OI part for you in my head. And over here, when you FOIL this one out, you get x squared minus 4x plus 4, and then you still have an x plus 2 over there. Okay, now it looks really complicated, except here's the thing. It's not a quadratic anymore, so that's exciting. So now we have negative 2x minus 8 equals, over here the negative 4x plus an x makes negative 3x, and then I have 4 and 2 makes 6. All right, so I'm going to add 3x to this side. I'm going to add 8 to that side. X equals 14. Whew, that was a good one. All right, last three. Hope you stayed with me this whole time, and then you're headed to the beach. All right, the reason why I took out this one is because, well, first of all, chapter 9 was all about arithmetic and geometric series and sequences. And this one says to write a recursive and an explicit for each of these. And this one looked okay at first. It was increasing by 5 until here it jumped to increasing by 10. So you actually can't write an explicit formula for that one. So, okay, but this one you can. This one right here is, looks like we are multiplying by 10 each time. And so if you remember, that is a geometric sequence. And to write a recursive formula for this, you first need to tell me where to start. A sub 1 is 1. And then to get to the next term, you're going to take the previous term and multiply it by 10. So that right there would be recursive. Now, if you don't remember these formulas, they were given to you, so you could look them up in chapter 9. And then for explicit formula, geometric was given to you, a sub n equals a sub 1 r to the n minus 1. I don't know if you remember that, but that's given to you also. And so for this one, it would be a sub n equals 1 times 10 to the n minus 1. So that's the explicit formula. Now, when it asks you to then find a sub 10, you would want to use this formula. You don't really need that 1 there. And you would find, to find a sub 10, you would plug in 10, which would be 10 to the 9th, which is going to be a pretty large number. 1 with 9 zeros after it. A bunch of zeros. Okay? All right. And then this one, it looks like we are multiplying by 2 each time. So it's another geometric, which there was an arithmetic one here, but there isn't. So you start with 3, and then to find the next term, you're going to take the previous term, which we call a sub n minus 1, and multiply that by 2. Okay? And then for our explicit, so that's recursive, explicit would be a sub 1 r to the n minus 1. And you can check to see if that explicit formula works. Like, for example, if I plug in 3 in for n, I better get 12. If I plug in 4, I better get 24. And they want us to find the 10th term. So I would go 3 times 2 to the 9th power. And that gives me 1536. There you go. All right, that's it. Thanks. Thanks for stopping by.